All right. So what is EF Core? EF Core is an object relational mapper that enables .NET developers to work with the database using .NET objects. It eliminates most of the need for the data access code that developers usually have to write. It is open source from Microsoft. It's developed in the open at Microsoft, so it's not like they're just dumping source out there and we're all just sort of read-only on the source. They get lots of external contributions from people, and they take issues from everyone along the way. It is completely rewritten from EF6, and the current version that we're on was released May 30th of this year. So why did we make a provider for SDBMS or ISAM? We wanted to support the tooling that layers on top of EF Core. So other bits of tooling use that EF Core provider, and they speak a common language, and they deliver some kind of value to you. And in our particular case, it was the libraries that enable OData, but it can be used by other things as well. The EF Core provider also simplifies loading complex data from multiple ISAM files. So if anyone has used select join, has anyone in here used select join? Yes? So one of the more difficult aspects of using select join is how do you take the results that we give you and turn them into a set of objects. For example, if you have one leg of your join that has changed and the thing that it's joined to hasn't changed, it can actually be really confusing to write code that correctly pulls that bit of data out of the data set that was returned to you and turns it into an actual object. So we do that for you, and we make that a lot easier. What does it give you? So access to Synergy data, of course. This includes joins and all sorts of filtering type operations and the things that Entity Framework offers. It gives you optimistic concurrency. I talked about that a little bit in the prior presentation. It gives you isolated transactions. If you're doing one operation and someone else is doing another operation, you don't necessarily want to see the results of their unfinished operation because they might not succeed. You might, if you read stuff that they're working on but they haven't actually committed it yet, you could end up getting stuff that never existed. Like it wasn't supposed to be there, and you read it and you made a bad choice as a result. So your transactions are isolated. And it also gives you high performance and scalability. So we do a lot of tricks around file channels and managing them, and how do we make sure that we're not doing more work than we need to do. And also, how do we very, very quickly turn Synergy data into your object graph? Where does it come from? So it's part of the Harmony Core project. So I have a nice long URL there off of GitHub that takes you to the specific area inside our Harmony Core project for the EF Core provider. It comes from NuGet, and if you're really, really interested, we have our CI/CD running in Azure DevOps, and whenever we do a build, it pops out a CI build to that URL there. So that is a NuGet feed server, and if you ask it for the latest version of the product, it will give you the absolute bleeding edge, super latest version of anything that we're working on. So if you make a feature request and then we put it in for you, and you want to get those binary bits right away, they will be there. That's where they will be living until we do an actual release, and then it will go out on NuGet. Where does it run? Anywhere Synergy.NET runs. So if Synergy.NET is supported on a platform, this will be supported on that platform. So it's .NET Standard, and that means that it runs on .NET Framework 4.6.2 and up, and it runs on .NET Core 2.1 and up. How does it work? So I've mentioned Synergy Select a bunch of times. Essentially, what goes on is we take a whole bunch of operations and a graph of instructions that's coming from Entity Framework and Link, and we turn it into a Synergy Select statement, and then we run that synergy select statement, turn the results of that synergy select statement into your objects, and then return those objects out to you. So we use synergy select, we use where, we use join, we use the order by, and we use link expressions to drive that, and we use a whole lot of code gen templates in order to make it really fast. Those code gen templates are built off of your repository. So your repository is what tells us how everything works together, and again, is very important for how we make this thing run very quick. There are a bunch of different ways that you can write queries. So system link expressions is, who here has actually heard of link before, L-I-N-Q? Yeah, so all the examples that you would see for link, they're system link expressions, probably. So the C# and VB compilers produce this out of a special syntax, but inherently they aren't about a special syntax. That's just something that the compilers will do for you. They are just a set of objects that represent instructions that get run at runtime. Those are one way to generate queries. Another way is with a project called System Link Dynamic. And so that's a set of method calls in addition to basically strings. So similar to like a SQL select type statement, but just for specific parts of it. So you're intermixing method calls as well as some kind of filter expression as an actual string literal. And parameterization and those sorts of things fit in there as well. And a third option to make it easier is we've taken sort of the common operations that we think that you're going to perform with the provider, and we've made extension methods that make those really easy and really fast. So they sit on top of system link expression and system link dynamic, and they basically just keep track of, have I already done this before? I'll just use the expression that I created last time I did this, so that things are quick. So what does that look like? I have a really, really basic answer here for some C# link. And the idea is that I have a context that's been given to me probably by dependency injection. And I know that I have some kind of entity set. In my case, it's customers. And I just want to get the first one where the customer number is greater than or equal to 8. So that top expression there, it goes to the context, looks at customers, and says, just give me the first one that you can that's greater than 8. And that converts down into a synergy select statement. It reads one record, returns it back, makes the object, and gives it to you. Slightly more advanced, but still pretty basic. We're doing the same thing to customers, and we're saying, we want to get back the customers where the customer number is bigger than 8. And by the way, we would like to join that customer that gets returned back to also receive their favorite item. So we're gonna look at the keys, and we're gonna go do a select join. And for all the customers whose customer number is greater than 8, we're gonna also grab their favorite item and return that back to you. This is basically that same query, just with system link dynamic. So we're having the customers. We're saying, give me back the customers where the customer number is 10. So we have that little placeholder there, and then the actual value to the right. So customer number is 10, and the city is New Orleans. So it'll go find that, and then it's going to order them based on their customer number. In our case, there's only going to be one, so my order by was kind of pointless, but I'm just showing you that you can do order bys in this world. And the helpers. So the helpers do the sorts of things that the system link dynamic does, but they wrap them up and make them compiled. So first or default including is like that first or default. So grab me the first one that matches this and expand this item. So do a select join and give me back the results from 2 different files. First or default without the word including just gives me back a customer that matches the expression. Where, as opposed to first or default, gives me back all of the things that match that filter. And then where including is a lot like the first or default including. It's going to match the qualifier and also do the select join. And that can work for multiple items at the same time. as evidenced by the second one. So I mentioned something about transactions. Over the years, I've heard the word transactions come out of more than 0 customers' mouths. So what am I talking about with this transactions business? So what we have is read committed level transaction isolation. So you can't see what everyone else is doing until they actually do it. We achieve that with optimistic concurrency based on GRFAs. And nothing is actually written to disk until someone calls save changes on your DB context. So some kind of request has come in and you've started processing things and you're reading records off the disk and you make a whole bunch of changes. If you don't actually call save changes, nothing happened. No one ever wrote anything to disk. But once you say save changes looks at all the objects that it has known about. So everything that it's tracking, all the objects that it returned, it knows about them. It knows what you've changed in them. And it produces a change set. And then it sends it to the underlying provider. And then we store it. So save changes either succeeds or fails in its entirety. There's no in between other than someone physically pulling the plug from your machine in the middle of a transaction. It will either succeed or it will fail. And if it fails, there's no leftovers. It didn't write things to the disk, or it cleaned up after itself if it did. Sounds nice, but how? How have we done this? I've spoken of dark magic. How did we actually do transactions with Synergy ISAM files? So here's the flow. You've done a bunch of operations beforehand, and you've made changes. So we've run your logic. We've read things. We go into save changes. We lock all of the records that are going to be updated or deleted. So we're using manual locks to do that. We create any new records that need to be created, and we hold a lock on those created records. Then we actually do the update operations on the records that we have locks for update. And then we actually do the operations that we have locks for delete records. And then we unlock everything. There's a little squiggle there that says this is where we have locks held for. So they're not long duration locks. They're very short. It's literally just we are going to read, lock, update, and then get out. What happens if there's an error? So inside of that, if we have an error while we're locking records, no problem. We unlock all the records. Nothing's changed. We haven't modified the database at all. It's fine. We just unlock everything and get out. Throw whatever the error is, and you guys can deal with it. So if the record didn't exist, or if it changed out from under us, or the GRFA didn't match, or the server was no longer accessible, none of these are a problem because you haven't actually written anything to disk. So the rollback was very easy. So these are just the different ways that this step can fail. And the only thing that we never have an answer to is someone pulling the plug. Although in this case we haven't written anything to disk, so it's okay. So if I'm in the create and lock new records phase of things, what happens if I've written 10 records and then the 11th one fails? I was unable to create a record. Maybe I ran out of disk space, or maybe there's a secondary key that's a duplicate of something else that's already written to disk. And that key doesn't allow duplicates, so it's going to fail. You can't write that record to disk. So we get that failure, and we've kept track of all the records that we've written to disk so far, and we hold locks on them so no one can grab them out from under us. And we just go get rid of them. It's like they never existed. We held the lock so no one else could do anything to them. So we just undo what we did. Hardware failure, we're going to roll back whatever we can. Again, if you pull that plug, we're dead. We're not running anymore. We can't undo things for you. What happens if you get a failure while you're actually updating records? So we've created 15, 20 records. That worked well. We didn't have any issues. So I have all of these records locked, so no one can grab them out from under me. But what happens, again, if I've changed a key value that allows updates, but I've introduced a duplicate, or I've run out of disk space, and the compressed record size has changed, so I end up actually consuming more space in the disk, what happens? Well, in reverse order now, we undo all the records that we wrote, because we have the original values for those records, so we just write them back. And then we delete all the records that we created in reverse order, and then we unlock everything and we get out. So nothing has changed on disk at this point. Same deal with hardware failure. We will roll back whatever we can, but if you pull the plug, we're dead. Once we get into the delete records phase, there's not a lot that can fail. There's actually nothing that can fail other than pull the plug, and then we're dead. If you pull the network cable and we're talking over a network, yeah, we can't finish deleting those records. But there aren't any other failure types that ISAM can experience other than actual hardware failures. So we will attempt to roll back anything that we can. If we are not allowed to write to that data file for whatever reason, then obviously we can't write to that data file. We can't roll anything back. And the last stage on that is everything gets unlocked because if we've made it to step number 6, we were successful and it's done. So I mentioned manual locks, and a lot of people have some mild post-traumatic stress disorder when they hear the word manual locks because maybe they've locked themselves out of things in the past. So we manage them and we keep track of them, and it's a very organized process, and it happens from top to bottom. And there's lots of guards around it so that the locks are short-lived. We will not lock ourselves out, and all of the channels get cleaned up after we're done. It's very helpful that EF Core coalesces changes made to a single object. So if you change this field 10 different times, we only get one answer to that. We don't try and store that record 10 different times. We get one record worth of change, and we go do that single operation. How do I avoid reading uncommitted data? So we use locks to prevent you from reading uncommitted data. So as long as you don't use read regardless of lock, you will never see things that are in process. If you are okay with seeing things in process, you can use read regardless of lock. And that's not really an issue, but you have to know that you lose that bit of transaction isolation if you are ignoring the locks that are being held on those records. So locks in this environment are very short-lived. So by default, the provider's interaction with locks is to just wait. So it doesn't poll. It uses the wait model of up to a second. This stuff is configurable. So you can choose how long you're willing to wait for things. But what do I do if I've acquired a bunch of locks and someone else has acquired a bunch of locks and they're holding something that I need to progress and I'm holding something that they need to progress? We're just going to get stuck. And eventually one of us is going to time out, and then the other one will be successful. So this transaction will fail and that one will continue because they were both deadlocked. But it won't stay permanently locked because of the timeouts. So is this ACID? So ACID is a term for basically how durable, isolated, and consistent your database is. Can I write a transaction and trust that when that transaction is completed, that data that I modified won't go anywhere, that it's there, it got written to disk. So that's durability. And yes, we have durability with flushing. In Roger's Futures slide, he talked about enhancements to that durability to make it less of a performance hit, and that's obviously very important to us because we want durability and we want to be able to turn on that flushing and we want those guarantees, but we don't really want to pay for it. So it's great if we can just pay less for that durability. I talked a lot about the isolation levels that we have, so read uncommitted and read committed level isolation. So we have those. We have consistency, but we have a pretty limited set of rules. So you define those rules in your XDL files and in your applications. So yes, we have consistency. The atomic nature of our operations isn't quite there. So everywhere in that flowchart where I said, this works except for if you pull the plug, that is a requirement. We have to survive getting the plug pulled out from under us in order to say that we're ACID. So that is the one bit of the acronym that we do not have here. So we don't handle hardware failure at all. But that's, something for the future. So we're obviously reading and writing data, but you guys might have your own way of reading and writing data, especially writing data and validating that data. So we support replacing our I/O routines with your I/O routines. And it's relatively straightforward, and it's a pretty simple interface to implement. It is a data object I/O base, and you implement the methods that are listed there. And then we will call your versions of things instead of our versions of things. And then we have lots of support that assumes that that interface is implemented, and we provide the additional features and functionality on top of that. There is a requirement that your implementation has to support GRFAs and manual locks. So you don't have to manage those manual locks. We still manage those manual locks, but you have to there are flags on the routines that you implement that basically say, I am trying to get a manual lock on this record, please go lock this record. So as long as you pass that through, everything will work great. So I keep talking about this thing being really fast, but like why? Why is it fast? File channels are not free to open and close. They are costly to open and close. If you close a channel on a Unix platform, it flushes everything that's been sitting around waiting to get flushed, regardless of whether it's your channel or not. Everything gets flushed, so there's a performance hit just closing a channel. It means all those nice warm caches get blown right out. So we don't want to open and close channels on a regular basis. And having a channel manager that can deal with that has a significant impact on the performance of your application, especially with XF Server. So opening and closing channels to a remote system is expensive. Opening and closing channels to a remote VMS system is very expensive. And you do not want to open and close those channels, so we don't. Data object metadata base, that's just a piece of infrastructure that we have around CodeGen, and that's where we pool a lot of memory allocations, and that's where we have really fast construction of complicated objects. So that materialization stage where we're going from a Synergy record into an object graph, that gets done by the code-generated code that's supported by data object metadata base. Add DB context pool. This isn't something that we provide. This is something that the EF Core team provides. And again, it's about pooling. So the less stuff that gets constructed, the less connections that get opened and closed, the faster things go. Lower latency, higher throughput. And part two of why is it so fast? Everything is compiled. We use compiled queries absolutely everywhere in our EF Core provider. And we've gone through a lot of effort, like a really very, very large amount of effort to maximize the amount of work that gets done in that compilation phase rather than waiting for runtime. So prepared query plans have taken your EF query and they've ground away on it for a while, and then they've produced, this is the plan, these are the select objects that I'm going to create, these are the join objects that I'm going to create, these are the files that I need to open, and these are the buffers that I'm going to use. And that way, once that thing gets created, we just run it. And it runs in essentially the same amount of time it takes to just new a select statement. So that comes from the automatic query cache in EF Core. So every time any query gets run, it runs through their query cache. And they relatively quickly identify, have I ever seen this query before? Was it parameterized? Can I just use this thing? And then it runs the query through the prepared query plan. You can also explicitly pre-compile queries. So if you have something that you know is going to get used, you can turn it from a big expression into a delegate that takes parameters and returns data. It's no longer doing any compilation phase stuff. It's just running what you've asked it to run, and there's no more overhead left over in it at all. So that is an excellent way to get really, really fast queries. But you say, my files are strange. We have tag fields that identify the record type and a whole bunch of multi-segment keys and foreign keys with literals, and some of my files have allowed dupes, and yes, all of those things work. We have discriminated tag fields, so you can have different data types coming out of the exact same file, and it chooses based on what the tag field is. So when you ask for customers, you'll only get customers, even though for whatever reason you have customers, orders, items, and vendors all in the same file. We know what the difference is, and we only give you back the thing that you're asking for. There's a lot of support in there for multi-segment keys. They get glommed together and turned into your whole segment, or they get used as a partial segment, just like you would use natively if you were writing this query by hand. And foreign keys with literals are also supported. So we just bolt on that literal. You don't have to deal with it. You're just following a navigation link. And the cogen stuff under the hood and repository takes care of all of that for you. Is this a replacement for XFODBC? Probably not. I don't know. Does it sound like it's a replacement for XFODBC? If it sounds like it's a replacement for your usage of XFODBC, talk to me about that, and I'll see if I think it's a replacement for your XFODBC, or if there's something that I need to do in order to make that not a bad idea. Or if maybe it's just a really good idea. So if this looks interesting to you, please talk to me about it later. Does this work with XF Server? Yes, it does. There are some special considerations. OpenVMS generates GRFAs instead of storing them in files, so they are a little bit more expensive. Tuning your query is more important when you're using XF Server. So we want to make sure that the kinds of data that are going across the wire are amenable to being sent across the wire. Use the logs. We have a lot of logging in SDMS and XF Server that tells you all the stuff that we're doing under the hood. So it's not magic. You can actually watch what we're doing internally and use the logs and find out, did it do what you thought it was going to do? Or did it do like 100,000 times more than what you thought it was going to do? In which case, either we need to fix something, or you might need to change your query. The other concern with XF Server is if you want to have one XF Server connection for your entire process, you don't have to do anything. That's already handled for you. If you want to have more than one XF Server connection for your process, one per thread, then there's work that needs to be done there. And that work gets bundled up inside of threaded context base in Harmony Core. So that's one of the pieces that works together between the EF Core provider and Harmony Core in order to let you talk to multiple XF Server connections at the same time. And this is obviously important for high scalability scenarios, because if you're just talking to one XF Server for all of your requests, it's a bottleneck. You had like 6 different threads working at the same time, and they all ended up in one connection, and that obviously is the same as having one thread working on stuff instead of 6. So a lot of people use I/O hooks. Do they still work? Yes, they work. The way that you implement them is you inherit from this class, and you use dependency injection to tell the world about it. So essentially, whenever we open a file, we will call your method, and you get to decide, I want to put this I/O hook on it based on the file name, or not, and in which case the file gets opened, the I/O hook either gets added or doesn't get added based on whatever you guys choose, and then we go about using that channel. So yes, I/O hooks work. Can I have it now? Yes, you can. Any questions?
So the first one is, what happens when you wind up with a deadly embrace. Do you have a timeout on your locks?
Yes.
Yes.
Everything has timeouts.
Okay. Can this work alongside existing traditional application updating the same files, or should all go through this stuff?
So yes, it works just fine side by side. The rules are essentially, if you read regardless of lock, you will see the innards of our transactions while they're occurring. Your code that's not using the entity framework provider won't be protected by transactions, but that doesn't preclude you from intermingling them. It just means that you won't get magic benefits from the code that's not using the provider.
Excellent. Can you update a record without unlocking it? If you have to roll back after updating some records, could someone pick up those updated records before rollback?
Yes, you can actually. One of the options in update, I guess it's write. So you can tell it, please continue holding this lock even after I have written the file. And in fact, that's what we do. We hold the locks until the very last stage, even though we've created with lock and updated with lock. So yes, you can.
Okay. How does the XF server license work on multi-threading?
So there is one XF server license per XF server connection. So if you use a threaded model where you say, for each thread that I'm processing stuff with my web server, I have one XF server connection, you will have that number of XF server licenses consumed.
Okay. And does the uncommitted read also ignore transactions in progress by other processes?
There are locks in the file, so it doesn't care whether you're in process or out of process. It uses ISAM to do all of these operations. So this isn't, the transactional support here isn't really some magic sprinkling of awesome dust on top of this running process. It's using the underlying ISAM in order to implement all those behaviors. So yes.
All right. Thank you, Jeff.
All right. Thank you.